Hello everyone and welcome back to Dev Portal. In today's video, we are diving into the world of intermediate operations in Java Stream API. These operations allow us to filter, transform and manipulate data efficiently. By the end of this tutorial, we will have a solid understanding on how to use each intermediate operation individually and how to chain them together to create a powerful data processing pipeline. Let's get started. Intermediate operations in a stream allow us to transform, filter and sort elements in the stream without consuming it. The key thing is to know that intermediate operations are lazy. It means they do not execute until a terminal operation is called. This allows for optimized and efficient processing in the stream. First, let's talk about filter method. The filter method allows us to select elements based on the specific condition. If an element matches the condition, it is retained, otherwise it is discarded. This is particularly useful for tasks like filtering a list of users by specific age group or filtering out the null values. Let me show you a small example. I have already created a list of names where I have added few values, and now I will use the filter method. So let me write filter method. So I will write names dot stream dot filter. And here I will select only those names which will start from capital H. So I need to write name, then I will write name dot starts with capital H. And then what I will do, I will print those values. For each loop I will use, and I will add system dot out dot println. Let me save and run this code. And you can see it is printing the two names, that is Harshada and Harika. Here we filter names that starts with capital H only. So Harshada and Harika passes the condition, so they are printing out. The filter method is perfect for refining data based on the condition. Now let's talk about map method. The map method is used to apply a function to each element in this stream, efficiently transforming each element in the sense. This is great to converting elements to the different form, such as converting string to uppercase or calculating the square of each integer in a list. Let me show you the example for that as well. So what I will do, first I will write map method, and now let me add names.stream.map, and here I will convert it into the uppercase, name dot to uppercase, and again I will print all the values, and I will add system.out.println statement. Let me save the code. One more thing let me do, let me add sysout statement and add the partition. Let me run it again, and you can see it has converted all the names into the uppercase. So here we transform each name to the uppercase. The map method is excellent when we want to apply a function to all the elements in the stream. Now let's talk about flatMap. The flatMap is essential operation where we are dealing with the stream of list or other nested data structure. It allows us to flatten multiple nested lists into a single stream, making it easier to process element individually. So let me show you the example. Before that I need to create one nested list here that will be of list of string. So list of string, and let me give some name nested list, suppose equal to, let me create arrays dot as list, and here I will write arrays dot as list again, and let me give two names here, suppose Janet, Shreya, and another one arrays dot as list, this time Aman and Sahil. Let me save. So our nested list is created. Now I am going to use the flatMap method. So I will write nested list dot stream dot flatMap, and here I need to use collection double colon stream. So it will convert it into the flatMap dot for each and sysout statement. Let me save this code. Let me import collection as well. And before printing, let me add sysout statement as well for partition. Let me run this code now. And you can see it is printing the elements. We have created a nested list, but you can see here it is printing the elements in the sequential order. So in this example, flatMap took each sublist and flattened them into the single stream, allowing us to access each name directly. This is ideal when we are handling nested data and is widely used for data processing. Now let's talk about distinct method. Distinct method is straightforward but very powerful to remove duplicates from the stream. This is particularly useful when we need to eliminate repeated elements in the collection. So for that, let me add one duplicate value here. Let me add Aman again. And now what I will do, this is the example of flatMap method. And now we are going to use distinct method. So I need to write names dot stream dot distinct, and it will give me the stream of distinct elements that I will print it here. So again, let me do one thing. Let me add sysout statement for partition. Let me save and run. And now you can see it is printing distinct elements. If I print the values again, stream names dot stream dot for each, so you can see it will print the duplicate value, that is the Aman. So you can see it is printing Aman twice. So this is about distinct method. Let me remove it. Now let's talk about sorted. The sorted method allows us to sort elements in the natural order, or we can also use the custom order if we provide a comparator. Sorting is commonly used in application like ordering a list of names or sorting numbers. Let me show you. So what I will do, I will write names first. Let me add comment sorted method. So I will write names dot stream dot sorted, and first I will show you the natural sorting dot for each, and I will add sysout statement, and before that I will add sysout statement for partition. Let me save and run, and you can see it is printing the elements in the sorted order, and it has printed Aman twice because it is present twice in our list. This is the natural sorting. Let me show you the custom sorting as well. Custom sorting. So I need to write names dot stream dot sorted, and here I will provide the comparator operator. So I need to write comparator inside this sorted method, CMPA comparator dot reverse order. Now it will do the sorting in the reverse order that I will print using for each loop. Again I will add sysout statement before to add partition. So now you can see it is printing the elements in the sorted order but in reverse order. So this is about sorted method. Now let's talk about peek method. This method is mainly used for debugging purpose. It allows us to look at each element in the stream as it follows through the pipeline without modifying it. This will be very helpful when we debug the complex pipelines. Let me show you. So this is about peek method. So I need to write names dot stream dot, and suppose I want to use map, not map, first I want to use peek so that I can see what values it has. I will add sysout statement, and then I will apply map method, and I will convert these values which are present inside the list into the uppercase. So name dot to uppercase I will use, and then again I will print those values using for each loop. So let me add sysout statement, and now we are going to see it will print the elements twice. So here you can see first it has printed Harshada, and then it has converted into the uppercase, then Janet, and then again converted into the uppercase. So here peek method prints each name before transforming into the uppercase. This is useful for tracking the flow of the data through the pipeline and understanding how each operation affects the stream. Now let's talk about limit and skip. The limit method allows us to restrict the number of elements in the stream, which is very handy in case of pagination, and skip let us bypass the specific number of elements which can be used for the similar purpose. Skip we can refer as the offset that we use in the database, and limit as we use in the database, it has same meaning. So now let me show you the example. So first let me show you the example of limit method, and I will use name again dot stream dot, and now I want to limit the output, so I will write limit and I will provide the value, suppose 3, only 3 values I want, dot for each, and now let me add sysout statement. Before printing, let me add sysout statement again for partition, and I will divide it, and now let me save and run the code. So you can see it has printed only the 3 values. Now same way let me show you the skip method. Names dot stream dot skip, and I need to mention how many elements I want to skip. Suppose 2 I want to skip, dot for each, and I will print the values. Let me add sysout statement again. Let me save this code, and now you can see it is printing only the 3 elements. Why 3? Because we have total 5 elements. Suppose if I skip 4 elements, now it will print only 1. You can see it is printing only 1 element. So this is about limit and skip. Now let us combine some of these intermediate operations to create a more complex pipeline. Suppose we want a list of numbers and we want to filter out even number first, and then we will square them and remove duplicates and sort them in the decreasing order, and we will achieve this in a single pipeline. Let me show you. So first I need to create list. Before that let me add complex pipeline. Now let me create list of integer numbers equal to arrays dot as list, and I will add 1, 2, 3, 4, 3, 5. Now let me write numbers dot stream, and first we need to filter even numbers. So only 2 even numbers are there, so let me add few more even numbers here, 6, 8, 8. Now it is better. Now I will use filter to filter out even numbers, and I will write e when e is divisible by 2. When it returns modulo 0, it means it is divisible by 2, so it will return me the stream of even numbers. Now with this I need to square those numbers, so for that I can use map, and here I can provide what implementation I want to write. So I will write e, then again lambda function e multiply by e. It means I have multiplied the element with itself, and then I need to sort the elements, and before sorting I need to remove the duplicates. So let me write distinct, and then I will do the sorting on the reversal order. So I will write sorted, and I will write comparator dot reverse order, and then I will print those elements. So that's it. So before that let me add sysout statement. Let me save this code and run, and you can see it is printing 64, which is the square of 8, then 36, that is a square of 6, then 16, and then 4. If we want, I can show you one more thing. If I want to use limit and skip method, so in that case what I will do, first let me add sysout statement. I will remove the distinct method and I will apply limit and skip. First let me remove distinct, and let's see how many elements it is printing. So it is printing total 5 elements. Now I will use limit, and I will provide limit, suppose 2 elements I want, and before providing the limit I want to skip. Dot skip, I want to skip the first element, and I will write for each loop, for each, and system.out.println. Let me save this code, and now you can see it is printing 2 elements. One element I have skipped and it has sorted the elements. So before this, let me do one more thing. Let me remove skip and limit so that we know how many elements are there. Let me save. Okay, here I forgot dot. Now let me add sysout statement, sysout, and let me add the partition. Let me run this code, and you can see total 5 elements are there. One element I have skipped, that is 64, and then I ask for 2 elements, that is 64 and 36. If I change it to 1, or before changing limit I can change skip to 3. Now if I print, let me save the code and print, you can see it is printing 16 and 4. If I again change skip to 5, now let's see what it will do. It will print nothing. So here in the above example, what is happening? Filter we keep only for even numbers, then we use map to square each number, then we have used distinct to remove duplicates, and then sorted to sort the numbers in the decreasing order, and then we use the for each method for finally printing each element. This example shows the power of chaining multiple intermediate operations to create efficient data processing pipeline. To sum up, intermediate operations in the Stream API give us incredible flexibility to filter, transform, and manipulate data in the concise, readable, and efficient way. By chaining these operations, we can create powerful pipelines for data processing, and the laziness of Stream ensures that operations are only executed when necessary. In the next video, we are diving into the terminal operations, where we will learn how to gather, reduce, and aggregate data from Stream. Be sure to like, subscribe, and hit the bell icon to stay updated with more Java tutorials here on DevPortal. Thanks for watching, and I will see you in the next video.